Algebra 1 Common Core, Unit 8, Section 4, Completing the Square. So this is coming after the video 8.3 of the quadratic formula. And the quadratic formula is very useful to us because prior to that we were factoring to solve for the roots. And we always ended up with rational, nice, whole number roots, some occasionally fractions, but they were all rational. Well, the quadratic formula was nice because sometimes the roots of a quadratic are not integers, sometimes they're not fractions, sometimes they're not rational at all. And the quadratic formula can help us solve those tricky decimal root questions. And so the quadratic formula is nice, and that's a very useful formula. And we see that here from the previous video. Completing the square is less of a formula and more of a process. But it does the same thing as the quadratic formula. So basically, we can use this just as we use the quadratic. We're still going to use it to find the roots. Now, the quadratic formula, the completing the square process has a lot of other applications. Like in the next video, 8.5, we're going to see how it helps us convert to something called vertex form. When you get to geometry next year, you may use it to put circles in standard form and different things. So completing the square has a lot of other uses other than solving for roots like we're about to do right now. But for the purpose of this video, that's what we're using it for. We're pretty much trying to do the same thing we did here. So like this question on the last video where we did the quadratic formula and we got 2 plus or minus 1 rad 6 over 2, we can use completing the square to get that same answer. It's a different process. It's a different option. There are times where maybe one is a little easier than the other, but like I said, they have different uses at different times, but at times they can do the same thing. And right now, they're doing the same thing for us. They're helping us find the roots of a quadratic. I want to know where a parabola is crossing the x-axis. And it may not be rational, so I need something. And I can use the quadratic formula, or I can do completing the square. But it's important that you know how to do both of these things. Yes, sometimes you may be able to have a choice. You can do quadratic formula or completing the square. But there are times where a problem may require you to do a specific one. So you need to be very familiar with both. So what's the process? Well, solve a quadratic equation by completing the square. So a normal quadratic equation. Again, we could start off with it equal to 0. But this is what's a little unique about completing the square is it's the one process that we actually don't keep it equal to 0 the whole time. The first step is actually setting it equal to the c term. So the c term, which is your constant, in this case positive 3, that gets moved to the other side. That would say a positive 3 on the left, so we had minus 3 on both sides, so it becomes a minus 3 on the right. So you actually put the constant over there. You don't want anything, you don't want the a terms or the b term, just the c term over there. And then the next step, which is probably the trickiest step, or maybe the weirdest step in completing the square, is that we add something to both sides. And that something comes from its own little mini formula. It comes from this right here. Your b term divided by 2 squared. So our b term here is the negative 6. When you divide negative 6 by 2, you get negative 3. And when you square negative 3, you get positive 9. And so that's why we add 9 to both sides. You don't have to put the line under it. I'm just, kind of emphasizing add 9 to both sides here. And so that right there is kind of, a little strange, and you'll get comfortable with it. That's just, all right, take your b term, cut it in half, and you got to divide by 2 first. Then you square it. And it doesn't matter if it's positive or negative, it's going to square positive. Things always square to positive. Then, after we add that thing on both sides, the reason why we do that is we get kind of a new trinomial on the left, and it's what we would call a square trinomial because it factors perfectly to 2 of the same binomials. We factored a lot of trinomials, but they're usually not the same thing twice. This is why it's called completing the square, because it kind of makes a square trinomial. And so we could get it factored to the same thing twice, and on the right side you could just combine your like terms. Negative 3 plus 9 is 6. We could factor the left to the same thing twice, and it always ends up kind of just being your x and then half your b term, x and half your b term. But these are the numbers that add to negative 6 multiplied to 9, so it is just factoring. But what's good about this, because it ends up to the same, factoring to the same binomial twice, we could write it once squared. Because remember, x minus 3 times x minus 3 is x minus 3 squared. Then And again, this is a long process. It's really not that bad once you get used to it, but it's a long to explain. Then we're trying to solve for x. So we need to get rid of the squared. So we square root both sides. And so that's what you see here, square rooting both sides. And when you square root the right, you have to introduce the plus minus symbol. And that's that same symbol we see in the quadratic formula. Because again, we're going to get basically the same answers, like if we were doing the quadratic formula. So when you square root both sides, you have to put the plus minus in front of the square root on the right. And what happens over here is important. That when you square root the parentheses squared, the square root and the squared cancel each other out, and you're just left with the x minus 3, or whatever was in the parentheses. But it's no longer being squared, it's no longer being square root, because square and square root are inverse operations, they cancel each other out. And then the very last thing is I want x alone, so I have to add 3 to both sides. And when I add 3 over here, these are, not like terms. So I can't combine, rad 6 and 3. So we just kind of put them next to each other, and you put the radical still last after the plus minus. Whatever number you bring over goes in the front. And so that's your answer. And so that's, if we were to do the quadratic formula with this problem from the start, we would still end up with this same answer. At least we should. And that's what I'm showing you down here. That if we do the quadratic formula, it still works out to be the same thing as completing the square. So I suppose if you had the time and you wanted to check this, you could use both methods, do completing the square and quadratic formula, and make sure you get the same thing. But all right, let's do one example of completing the square from start to finish. All right, so this one is set equal to 0 to start. That's good. That's usually where we like to begin, even though the first step is move the constant over. So the constant, I'm going to add 3 on both sides. That leaves me with x squared minus 6x equals 3. This is pretty much the same problem, except with a positive 3 instead of negative 3. Sorry, I didn't realize how similar it was. All right, so then the next step is going to be the what do I add to both sides phase, right? It's going to be x squared minus 6x plus something equals 3 plus something. What goes there? Well, again, that's your kind of a little mini formula on the side. It's your b divided by 2 squared. And our b term in this case is negative 6. So that divided by 2 squared. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I add 9 on both sides. Then we factor the left. Now it's going to factor to a double parentheses. It's a basic trinomial. We can simplify the right over here. 9 plus 3 is 12. Right? Just simplify those terms. This factors to the same thing. So it's what multiplies to 9, adds to negative 6, and is the same number, and it's negative 3. Again, the shortcut here is it always works out that it's half your b term. But the way that we're actually going to write it, instead of x minus 3, I mean, we could write it like that for that step, but then we write it as x minus 3 squared equals 12. Then we got to get rid of the squared, so we square root both sides. On the left, we're just left with the x minus 3 no longer in parentheses. On the right, we have to remember to now introduce that plus minus symbol, and that's what's in front of the rad 12. Now, we are going to have to reduce this rad 12. It doesn't really matter if we do it now or if we move the 3 over and then do it. It could go either way. Let's simplify it first. So here's rad 12. We need to be able to simplify it. The case up here that I did for a demo, rad 6, there's no square factors that go into rad 6 other than 1. But rad 12, yes, it could be divided by 6 and 2, but that's not going to work. It's going to require 4 and 3. And write it as 2 radicals that multiply to it, but one of them has to be a square. 3 is not, but 4 is. The square root of that rad 4 is 2. You have to square root the square number. The one that's not square stays inside. So this is going to now turn into x minus 3 equals plus minus 2 rad 3. And then the last thing is going to be move this 3 over. So I'm going to add 3 on both sides. Again, I can't combine these, so I just kind of put it in front of the plus minus. So my final answer is that positive 3 that I added over plus minus 2 rad 3. And that's our final answer. So that's the process. It's going to take a couple of days to really get comfortable with it. It is a process. You know, it's not a formula where I just plug in things. It is a procedure, a process, and you got to remember step by step what to do first. Move the constant, add the thing on both sides, factor left, simplify right, square root both sides, plus minus, simplify the square root, move the number. You know, there's a lot going on there for sure. So it definitely takes some practice. But this is an important procedure which is going to come up in every year for your next several math courses. So this and quadratic formula, these are two of the most important things we do in this entire year. All right, that's it for 8-4, completing the square. See ya.